This is SpaceTime, Series 23, Episode 64. Coming up on SpaceTime. New hints of hypothetical axion particles. Solar Orbiter makes its first close approach to the Sun. And NASA's new water-hunting Lunar Rover. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists with the International XENON collaboration have come up with some exciting new results that just might be opening a window on a hypothetical particle called the axion, which has been linked to dark matter. Dark matter is a mysterious invisible substance which makes up some 85% of all the matter in the universe. Although they have no idea what it is, scientists know dark matter exists because they can measure its gravitational influence on normal baryonic matter. The stuff that stars, planets, houses, cars, and people are made from. The quest to find out exactly what dark matter is remains one of science's biggest challenges. Now, a report on the pre-press physics website archive.org claims the world's most sensitive dark matter experiment, known as the XENON 1T, has come up with some surprising excess events which could help in the search. Now, the authors don't claim to have found dark matter, but instead say they've observed some unexpected rates of events which, well, they simply can't explain. The signature of this excess is similar to what one might expect from a tiny residual amount of tritium, which is a radioactive hydrogen isotope comprising a proton and two neutrons. But it could also be a sign of something more exciting, such as the existence of a long hypothesized particle called the axion, or possibly even an indication of previously unknown properties of neutrinos. The XENON 1T experiment was operated between 2016 and 2018 at the world's largest underground laboratory, deep below Italy's Gran Sasso. So far, the prime suspect for dark matter are WIMPs, or weakly interacting massive particles. WIMPs could be these long hypothesized axions, or they could be new types of neutrinos, or they could be something completely different. The thing is, we just don't know. But thanks to XENON 1T and experiments like it, physicists are now narrowing down the likely mass range where this theoretical particle could be hiding. In addition to dark matter, XENON 1T is also sensitive to different types of new particles and interactions, which could explain other open questions in physics. In fact, last year, using the same detector, the same team of scientists published observations of the rarest nuclear decay ever measured in Nature. In its simplest terms, the XENON 1T detector is a huge tank filled with some 3.2 tons of ultra-pure liquefied xenon, 2 tons of which served as a target for particle interactions. The idea is a particle would fly through space, crash into the Earth, not from above but from below, from the other side of the planet, fly up through the core, that's how weakly interactive these particles must be, continue up through the mantle and the crust, and through the XENON 1T detector from below. Very occasionally, one of these particles would strike one of the xenon atoms, in the process releasing a photon of light and freeing electrons. Photoreceptors positioned around the edges of the tank would then detect these interactions, letting physicists know something's happened. Now, the game here is that most of these interactions occur from particles that are already known to exist. So scientists have to eliminate these and estimate the number of background events in the XENON 1T experiment. And this is where it gets interesting. When the data from the XENON 1T was compared with known backgrounds, a surprising excess of 53 events, that's over the expected 232 events, was observed. And that raises the question, exactly where is this excess coming from? Now, one explanation could be a new, previously unconsidered source of background caused by the presence of tiny amounts of tritium in the XENON 1T detector. See, tritium spontaneously decays by emitting an electron with an energy similar to that was observed. And it would take just a few tritium atoms for every 10 to the 25 xenon atoms to explain this excess. Trouble is, there's no current independent measurements that can confirm or disprove the presence of tritium at that level within the detector. So a definitive answer to this explanation isn't yet possible. But more excitingly, another explanation could be the existence of a new particle. In fact, the excess observed just happens to have an energy spectrum very similar to that which is expected from axions produced in the Sun, assuming, of course, in the first place that axions exist. See, axions are hypothetical particles that are supposed to preserve a time reversal symmetry of the nuclear force, and the Sun could be a strong source of them. Now, while these solar axions wouldn't be dark matter candidates, their detection would nevertheless mark the first observation of a well-motivated, but as yet never before observed class of new particles. And that would have a massive impact on science's understanding of physics. And more importantly, other axions produced in the early universe could well be the source of dark matter. And if we have developed the technology to detect them, that opens the way to all sorts of other interesting experiments. For example, axions are thought to be the only particles that can travel faster than the speed of light. That's certainly one theory scientists would like to test. Now, alternatively, the excess could be due to neutrinos, weakly interactive subatomic particles, trillions of which pass through your body unhindered and unnoticed every second. The idea is the magnetic moment of neutrinos may well be larger than the value given in the standard model of elementary particles. That would be quite revolutionary and means there would be some new physics needed to explain it. Now, of these three worthy explanations considered by the XENON collaboration, the observed excess is most consistent with the idea of a solar axion signal. That's really exciting. Now, let's put that in statistical terms. This solar axion hypothesis has a significance of 3.5 sigma, meaning there's only about a 2 in 10,000 chance that this observed excess could be due to just some random fluctuation in the background rather than a clear signal. Now, while this sounds fairly high, it's still not large enough to conclude that axions exist. For example, physicists wouldn't confirm the Higgs boson until they achieved a 5 sigma significance. Meanwhile, the significance of both the tritium and the neutrino magnetic moment hypotheses also correspond to fairly high levels of significance, around 3.2 sigma, meaning that both of these are also consistent with the data, but just not quite to the same extent as the axion hypothesis. The XENON 1T is now upgrading to its next phase, the XENON NT, which will have an active xenon mass some 3 times larger and a background that's correspondingly expected to be much lower than that of the XENON 1T. With the better data expected from XENON NT, the XENON collaboration is confident they'll soon find out whether this excess is merely a statistical fluke, a background contamination, or something far more exciting, a new particle or interaction that goes beyond known physics. This is SpaceTime. Still to come, Solar Orbiter makes its first close approach to the Sun, and NASA's new water-hunting Lunar Rover. All that and more still to come on SpaceTime. The European Space Agency's Solar Orbiter spacecraft has undertaken its first close approach to the Sun, reaching a comfortable 77 million kilometres from the visible solar surface. In the week following perihelion, its closest orbital position to the Sun, mission managers tested the spacecraft's 10 science instruments, including its 6 onboard telescopes, which acquired close-up images of the Sun in unison for the first time. Solar Orbiter project scientist Daniel Mueller says these images are the closest ever taken of the Sun. Mind you, higher resolution images were taken by a 4-metre solar telescope in Hawaii earlier this year. But of course that was from the ground, so it had to do with Earth's atmosphere, which blocked out much of the solar spectrum visible from space. NASA's Parker Solar Probe, launched back in 2018, will be making closer approaches to the Sun, but it doesn't carry telescopes capable of looking directly at the Sun. On the other hand, Solar Orbiter's ultraviolet imaging telescopes have the same spatial resolution as those of NASA's Solar Dynamics Observatory, which takes high-resolution images of the Sun from an orbit close to Earth. So being 50% closer means Solar Orbiter's observations already have twice the resolution. The primary objectives of these early images is to prove that Solar Orbiter's telescopes are ready for future scientific observations when the spacecraft will be flying much closer to the Sun than its current orbit. The new images collected complementary data from various parts of the Sun, including the photosphere or visible solar surface, the corona or outer atmosphere of the Sun, and the wider, more rarefied heliosphere around it. Scientists will also analyze data from the 4 in situ instruments that measure properties in the environment around the spacecraft, such as the magnetic field and the particles making up the solar wind. It's the first time Solar Orbiter's in situ instruments have operated at such a close distance to the Sun, providing a unique insight into the structure and composition of the solar wind. Solar Orbiter launched on February the 10th and has now completed its commissioning phase and has now commenced its cruise phase, which will last until November 2021. During the main science phase that follows, the spacecraft will get as close as 42 million kilometres to the Sun's surface, which is closer than the planet Mercury. Solar Orbiter will reach its next perihelion in early 2021. But during its first close approach during its main science phase in early 2022, Solar Orbiter will swoop down to within 48 million kilometres of the Sun's surface. Mission managers will then begin using the gravity of Venus as a sort of gravity-assist slingshot, shifting the spacecraft's orbit out of the ecliptic plane, which is the imaginary plane around the Sun upon which the planets in the solar system orbit. These flyby maneuvers will enable Solar Orbiter to look at the Sun from higher latitudes, in the process getting its first ever proper view of its poles. Studying the activity of the polar regions will help scientists better understand the behaviour of the Sun's magnetic field, which is important because it drives the creation of the solar wind, which in turn affects the environment of the entire solar system. Since the spacecraft is currently some 134 million kilometres from Earth, it's going to take around a week for all the perihelion images to be downloaded through the European Space Agency's 35-metre deep space antenna in Argentina. The science teams will then process the images before releasing them to the public in mid-July. Meanwhile, data from the in situ instruments will also be made public later this year, following careful calibration of the individual sensors. This is SpaceTime. Still to come, NASA's new water-hunting Lunar Rover, and China launches a major cybering attack targeting Australia. All that and more still to come on SpaceTime. NASA's developing a new water-seeking lunar robotic rover, which could be exploring the Moon's south pole within 3 years. The Volatiles Investigating Polar Exploration Rover, or VIPER, will help pave the way for the return of humans to the lunar surface in 2024 aboard the Artemis 3 mission. The Artemis program is being developed by NASA using several commercial American spaceflight companies and international partners including the European Space Agency ESA, JAXA, the Japan Aerospace Exploration Agency, the Canadian Space Agency, and ESA, the Australian Space Agency. In 2024, Artemis 3 will launch aboard NASA's new Super Heavy Lift SLS rocket. It'll carry a crew of 4 aboard NASA's new Deep Space Orion capsule to the first modules of the new Gateway space station, which will be situated in near rectilinear halo orbit between the Earth and Moon. Once docked to Gateway, 2 of the Artemis 3 crew members will board a pre-positioned Human Landing System spacecraft for the final leg of the journey from Gateway down to the lunar surface, where they'll remain for up to 7 days. Landing in advance of the human crew will be a small flotilla of spacecraft carrying supplies and equipment and scouting out the surrounding area. The water-seeking VIPER robotic rover will be part of that project to develop a sustainable long-term presence on the Moon. Built by Pittsburgh company Astronomy, the $200 million four-wheeled VIPER will use the company's own Griffith lander to travel to the lunar surface. During its 100 Earth Day mission, the 500-kilogram box-shaped rover will roam over several kilometres using its scientific payload to sample various soil environments. Versions of its 3 water-hunting instruments are flying to the Moon over the next couple of years in order to test their performance on the lunar surface prior to VIPER's arrival. VIPER will also have a drill designed to bore down to at least a metre into the lunar surface. NASA's Associate Administrator for Science, Thomas Zurbruggen, says the agency's decision to send scientific payloads on an armada of small spacecraft to the Moon over the next few years in order to test the instruments that will eventually be used on VIPER is a totally creative way to advance lunar exploration that's never been done before. VIPER will collect data including the location and concentration of water ice that will be used to help develop the first global water resources maps of the Moon. The data will also help determine the landing sites for future Artemis missions by helping to find locations where water and other resources can be harvested to help sustain humans during extended expeditions on the lunar surface. VIPER's scientific investigations will help provide insights into the evolution of the Moon and the Earth-Moon system. Astrobotic is scheduled to make its first delivery of instruments to the lunar surface next year. In fact, NASA is now planning to send at least 2 science missions to the lunar surface every year. This report from NASA TV.
We know from decades of study that the Moon has water, but where and how much? In 2023, a robotic rover will explore the moon's surface in search of water ice. NASA's Viper moon rover will perform the first resource mapping mission on another world, using advanced instruments and tools to determine the location and concentration of water on the moon.
To send Viper to the moon, we're leveraging industry as part of our commercial Lunar Payload Services program, a program designed to send science instruments and technology payloads to the surface of the moon. Viper represents a very different development paradigm. We are developing each instrument for launch on eclipse ahead of Viper, totally flipping on its head how we normally do this. This is truly creative. An industry partner will launch Viper to the moon's south pole. This is a place where no human or rover has ever been before.
The rover's survey will provide scientists with the most detailed view of the moon's water to date and point to spots where water could be harvested by future astronauts.
Viper will be the first resource mapping mission on the surface of another celestial body. It represents a new kind of mission for NASA in which the objectives of advancing science and human exploration are closer than ever. The measurements that Viper's instruments will make can help us understand the source and distribution of the water and other volatiles on the moon, giving us insight into the evolution of the moon and the Earth-Moon system. The moon's water is also a precious resource that could be extracted to support human exploration of the moon and beyond. What we learn from Viper will bring us a step closer to developing a sustainable, long-term human presence on the moon.
And that report from NASA TV included NASA's Associate Administrator for Science, Thomas Zurbrücken, and Laurie Glaze, the Director of NASA's Planetary Science Division. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that 1 in 5 people worldwide, that's an estimated 1.7 billion people, 22% of the world's population, have at least one underlying health condition that could increase their risk of severe COVID-19 infection. A report in the Lancet Medical Journal claims the new findings are based on data modelling from 188 countries. However, the authors caution that their estimates are uncertain. That's because they're only focusing on underlying conditions, rather than other risk factors such as ethnicity, socioeconomic deprivation, and obesity. The research is only designed to provide a starting point for considering the number of individuals that might need to be shielded or vaccinated as the global pandemic unfolds. New studies have shown that the COVID-19 lockdown has changed human sleeping habits in North America and Europe. A report in the journal Current Biology analysed some 435 people in Austria, Germany and Switzerland, studying their sleeping habits over a 6-week period during some of the most severe restrictions of the lockdown. Researchers found sleep increased by an average of 13 minutes, although at the same time it seems sleep quality actually declined. Meanwhile, across the pond in the United States, scientists asked 139 university students to fill out daily sleep logs prior to and during their stay-at-home orders. And for Americans under lockdown, nightly sleep increased by around 30 minutes on weekdays, and participants reporting 7 hours or more sleep increased from 84 to 92%. Understanding the factors underlying these changes could help inform public health recommendations with the goal of improving sleep health in the wake of COVID-19. China's People's Liberation Army Unit 61398 has been identified as the primary source of a major cyber attack targeting Australian government, industrial, health, education and essential services. Cybersecurity experts say the Chinese Communist Party attack is probing unpatched vulnerabilities in Telerik UI, Microsoft's Internet Information Services, SharePoint and Citrix to try and gain access to computer networks. The Australian Cybersecurity Centre says the attack was designed to exploit public-facing infrastructure. If the initial attack failed, Beijing used various spear phishing techniques to try and gain access to individual computers through credential harvesting websites, emails with links to malicious files, links prompting users to grant authorization through Microsoft 365, and email tracking services designed to identify email openings and lure click-throughs. The idea appears to be Beijing setting the stage for some future crippling cyber warfare attack. These latest attacks follow reports that Australia's cyber intelligence agency, the Defence Signals Directorate, found that China's Ministry of State Security was responsible for a major attack on computer systems in the Australian Federal Parliament and that of political parties in the lead-up to the 2019 federal election. This all comes against the backdrop of Beijing's continuing trade war against Australia, following Canberra's push for an international investigation into the Chinese Communist government's attempts to cover up the extent and spread of its COVID-19 coronavirus. As well as intensifying its cyber attacks against Australia, Beijing's also issued formal warnings for Chinese students and tourists against travelling to Australia, and it's imposed 80% tariffs on some Australian exports to China. A German intelligence report has confirmed that Iran's mullahs are continuing their efforts to obtain atomic, biological and chemical weapons information. The 181-page Baden-Württemberg State Intelligence Agency document found the Islamic Republic, together with Pakistan, North Korea and Syria, are still pursuing these outlawed weapons to expand existing arsenals or improve the range and effectiveness of their existing weapons of mass destruction and develop new ones. The intelligence report found that the southern German state of Baden-Württemberg is a prime target for Iran's regime. It's because of the many high-tech companies that are based there. A new study shows that the same type of people who tend to be climate change deniers also consider the coronavirus a pseudoscience. Not everyone, of course, but a new investigation from the environmental publication To Smog shows a massive overlap between the climate science denial machine and the COVID-19 pandemic denial machine, using the same playbook they've been using to try and discredit climate science. As the COVID-19 virus spread around the world from its epicenter in Wuhan, China, so too did misinformation, predictions that the disease would not cause significant harm, claims of miracle cures, and conspiracy theories about the virus's origins. The study finds this misinformation is often being circulated by white-collar professionals, including many with a history of casting down on climate science or seeking to debate issues that have already been resolved within the scientific community. Tim Mendham from Australian Skeptics says there's also what Dr. Steve Novella from The Skeptic's Guide to the Universe refers to as an unholy alliance between COVID-19 pandemic deniers and anti-vaxxers.
I think there's a lot of overlap between a lot of conspiracy theories, especially those which are sort of anti-expert, anti-quote establishment, unquote, where they basically don't believe anything or don't want to believe anything that anybody says, especially when it infringes on their liberty. This is a big issue, obviously, in America, where the libertarian movement is stronger, but people sort of hear the same, and because they don't like government interference, and that's what climate change involves a lot of, and that's what coronavirus COVID-19 restrictions involves a lot of, so naturally the same people are against both. Now the story is about actually literally the same people behind a lot of these campaigns, so therefore there is an overlap between, it's a state of mind, it's also a state of politics, that they basically just carry on the same techniques, the same undermining of expert opinion, and attitudes like that towards various claims or various restrictions, regulations, that sort of thing that are going on. So there is a similarity. People were suggesting there was a similarity between the pro-tobacco lobby way back when and the climate change denialists.
Well, they were the same people. There was the same tactics being used, exactly the same tactics.
That's right, yeah, same tactics, same sort of lobby groups, that sort of thing. So there's obviously a bit of a profession out there in going against these things. The trouble with coronavirus, of course, is that there's a lot of unknowns about it, and therefore it's a lot of openings for various groups to try and sort of wield their wicked ways.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.